A quadrilateral is a two-dimensional plane figure that uses four line segments to enclose a space. Here are some examples. Quadrilaterals can be regular or irregular. Regular quadrilaterals have congruent sides and angles. Irregular quadrilaterals do not have congruent sides and congruent angles. The square is the only regular quadrilateral on our list. All the others are irregular quadrilaterals because they do not have congruent sides and congruent angles. A rectangle may have four 90-degree interior angles, but it does not have four equal-length sides. So, it is an irregular quadrilateral. Calculating area in square units for a square and rectangle is easy. Area equals width times length, which for a square can be width squared. If you have a square with sides 17 centimeters long, the area is 289 square centimeters. If you have a rectangle with two sides 17 centimeters and two sides 34 centimeters, the area is 17 times 34 equals 578 square centimeters. Calculating area for most of the other irregular quadrilaterals can be tricky. Area of a parallelogram or a rhombus, for instance, is its height or altitude times its base. With a trapezoid, you have to find the average of the two bases and multiply that times the trapezoid's height. A kite, which has two adjacent short sides and two adjacent long sides, has an area formula based on its diagonals, d1 and d2. In addition to symmetrical irregular quadrilaterals can exist without symmetry, just four unequal sides. To find the area of such irregular quadrilaterals, divide the quadrilateral into two triangles by constructing a diagonal that does not disturb the known interior angle. Calculate the area of each triangle using formulas, and add the areas of the two triangles. For our quadrilateral MATH, connecting the vertex A to vertex H breaks the shape into triangle MAH and triangle ATH. You do not know the heights h of either triangle, so you cannot calculate area using 1/2 of base times height. Instead, we must be creative by building one fact on another. Knowing the lengths of the sides and measure of one angle, we can use these four steps in sequential order to find the total area of our quadrilateral. Let's go through each step. Given the lengths of two sides AT and TH and their included angle T, use the trigonometric function side angle side to calculate the area of triangle ATH. We can plug our numbers into this equation. Then we solve for A, which gives us the answer A equals 15.588 centimeters squared. Next, we will use the law of cosines to calculate the unknown length of diagonal AH. First, we'll recast the formula using our labels, keeping in mind the sides of our triangle can be represented by the lowercase versions of their opposite angles. Side AT can be labeled H. Side TH can be labeled A. Side AH can be labeled T. Now let's plug in our numbers and solve for T, which is the length of side AH. T equals approximately 13.747 centimeters. Now that we have the length of the diagonal AH, we can use Heron's formula to calculate the area of the other section of our quadrilateral. Heron's formula depends on knowing the semi-perimeter, or half the perimeter of a triangle. For our triangle MAH, we have the measure of three sides. The semi-perimeter, S, is half the sum of the sides. So S equals 1/2 of 7 plus 13.747 plus 14. Our answer is S equals 17.374 centimeters. Now we have the measure of S, and here is Heron's formula. A, B, and C are the lengths of the three sides. Now we plug in the value S throughout and solve to get the area. At last, we have the areas of our two triangles. Add them, and you have the total area of the irregular quadrilateral. 15.588 centimeters squared plus 49.96 centimeters squared equals 62.548 centimeters squared.